Today I'm going to go over 4 examples under the topics future value of periodic deposit investment, present value of a single deposit investment, present value of a periodic deposit investment, and the last example will be the term, the length of a single deposit account. Let's get started. Example number 1. Future value of a periodic deposit investment. Barbara wants to restore her 66 Mustang in 4 years. So we have 4 years, that's for T. Let's put it right here. She puts $200 into an account, that's the deposit, $200. In an account every month. That's why it's called periodic. It's not like a CD, one-time deposit and she walks away. That pays 1.05 interest, that's R. Of course we need to write it as a decimal, so R is 0.0105. Moving the decimal to the left 2 places. Compounded monthly, that means N equals 12. And I have the formula on the right side and all the components defined just for reference. How much will be in the account after 4 years? So we need the balance, and that's missing. So the formula is on the right side. I'm gonna use it and put the numbers where they belong, and we'll move on. First of all, we have N times T. You could reduce that to N, which is 12, and T is 4. So we could write, instead of 12 times 4, write 48. That is part of the calculations to help us out. So B equals, we have 200. That's the principal, the starting amount. Open parentheses. Another one. 1 plus 0.0105 over 12. Close the second one, minus 1, minus 1, then close the first one that we opened for the numerator. The product of 200. All over 0.0105 divided by 12. So by typing those numbers on the calculator, you have to be careful. I need all this to be as one part, which is called the numerator, and I need this to be one part as the denominator. That's why I'm including parentheses right here, as you could see. It helps also to speak clearly for the denominator and give it parentheses. You don't have to, but it's better to group everything. To show you the calculations and save you some time, I have the following. So instead of, as I said, N times T, writing 12 times 4, I wrote 48 right here. And by typing it on the calculator, everything is right here, shows, and I have all the keys that I pressed right here. It's this much, but because it's money, we need to round to 2 digits. So we make it only 0.07. So putting $200 every month, that's called periodic. for 4 years, compounded monthly with this interest rate 1.05, will be equal to 9,800 something, almost $10,000. That's the power of investments and retirement plans. But this is only 4 years. Imagine if you do that for 20, 30 years. So that's number one. Let's move on to number two. Number two, present value of a periodic deposit investment. So we do have it as periodic, and that is deposit each year. Deposit each year. Bob wants $50,000 at the end. So we have $50,000 as the balance. That's right here. Of 7 years, that's T, 7 years, in order to buy a car. If his bank pays 1.2% interest, so that's 0.012 written as a decimal, compounded annually. Annually means n equals 1. How much must he deposit? So the principal is missing. Each year, that's periodic, in order to reach his goal. To do this right here, we have P equals 50,000, one more zero. That's for the balance B, multiplied by 0.012 divided by 1, because n is 1, all over 1 plus r, which is 0.012 over n, which is 1, raised to the power nt, nt, 1 times 7, and after we finish, we subtract 1. With the calculator, you end up with about 6,889.80. So that should be deposited each year, or deposit each year 6,889.80 for 7 years with that interest, which is a low interest. I don't know how these examples come up with these numbers. 1.2% interest for investments is kind of really low. Usually it's like 4% and higher, maybe 6%, sometimes 7%. But that's what we have, so we have to apply it. To show you more details, this is the number and this is the answer with the steps on the calculator to type it, as you can see. That should do it for number two. As you can see, I write my notes to save you some time from recording, because I don't want to end up doing those 4 problems in like an hour. So hopefully it doesn't take too long. Let's go to number 3. Present value of a single deposit. So you're gonna give them a single deposit, and we want the present value, knowing the balance at the end. Omar wants to open an account for his grandchildren that he hopes we will have $80,000. So we have $80,000. That's the balance. In 20 years, that's T. How much must he deposit? Question mark. Into an account that yields 1.75%. So 0.0175. Again, we write it as a decimal. Compounded monthly. Monthly, that means we're doing it 12 times a year. so n is 12, so he can be assured of reaching his goal. That's why the title is present value. What should we deposit now such that in 20 years, for that interest compounded monthly, we need to have, after 20 years, a balance of $80,000. The formula is written on the right side. We need to plug the numbers in, use the calculator, and finish it. So we have P equals $80,000. Let's put the fraction here and try to squeeze everything. $80,000 over 1 plus 0.0175 over n, which is 12, to the power 12 times 20 and that should be on a calculator equals to about 56,389.42 cents. So the present value should be that much, 56,000 something. In 20 years, with that interest compounded monthly, that will add up to a balance of $80,000. That is number 3 with the calculator and the keys that I typed on the calculator. One more and we'll be totally done. Number 4, the term of a single deposit account. So we're looking for how long. That's T equals question mark. Jasmine wants to start saving to purchase an apartment. Her goal is to save $225,000. That is our balance that we want to end up with, 225,000. That's the balance. If she deposits $180,000, that's the principal, $180,000 into an account that pays 3.12%. So the interest is 0.0312 to grow to the desired amount. Sorry, approximately how long? Approximately how long? That is T, question mark. It will take for her money to grow to the desired amount. Round your answer to the nearest tenth of a year. Now we are doing it monthly, so n is 12. We're going to be using 2 other formulas written on the side to make it happen. And here we go. We have B equals 225,000 equals 180,000 multiplied by 1 plus 0.0312 over 12 to the power 12 T. T is missing. So the main focus here is we're trying to find T. We're trying to find T. To reach our T, we need to use the logs of the 2 formulas written on the right side. First step, we divide both sides by $180,000. So we need to clean it up first before we move on. 180 so this now cancels. We could also cancel the zeros right here on the left to reduce it, And on the left, 225 divided by 180 is 1.25. So we have 1.25 equals 1 plus 0.0312 over 12 to the power 12t. Now, we could reduce the number inside. We could write 1.25 equals, dividing 0.0312 by 12 gives me 0.0026, adding 1 to it, that will be 1.0026 to the power 12t. Now, if you have something like this, a equals b to the power c, we could write it as c equals log a base b. Notice that b to the power c equals a, and that's what we have right here. Of course, b has to be greater than 0 for the base of log. So by rewriting this as log, we end up with log, the base is 1.0026, and the answer was 12t to the power 12t if you go backwards, and the argument is 1.25. Now I'm going to apply the change of base formula on the left side. This gives me log 1.25 base 1.0026 becomes 2 logs. That's log 1.25 over log 1.0026 equals 12t. Dividing both sides by 12 to leave t alone, I have the following. T by itself equals log 1.25 over log 1.0026 all over 12. Using the calculator, we could plug them in the calculator and we'll end up with about 7.2 years. It says round your answer to the nearest 10th of a year, and that's the answer, about 7.2. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.